So this is question number 5 of the 2019 AP Chemistry free response questions. And it says the complete photoelectron spectrum of an element in its ground state is represented below. In part A says, based on the spectrum, write the ground state electron configuration of the element and identify the element. So the first step here is to characterize these peaks correctly, right? So the one that has the most energy is going to be the peak of the orbital that's closest to the nucleus. So this peak right here is 4s2, and we know this is 4s2 or 1s2, because this peak has to be fully filled for these peaks to be filled, right? So 1s2, 2s2, 2p6, 6 for the same reason has to be fully filled, 3s2, 3p6, 4s2. And this is 2 because it's the same height as the ones that were 2 before. And if you look in your periodic table, 1s2, 2s2, 2p6, 3s2, 3p6, 4p2 is calcium. So the let's write out the electron configuration first. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Alternatively, you can use shorthand notation and find the noble gas, and that will be argon, right? So this entire first part of the configuration can be abbreviated with argon, and then a 4s2, and then double I, the element is calcium, or just Ca. Part B says calculate the wavelength in meters of electromagnetic radiation needed to remove an electron from the valence shell of an atom of the element. So, part B, you need to use two equations here. You need to use E equals Planck's constant times frequency, and the speed of light is equal to wavelength times frequency. Planck's constant, you know Planck's constant, or you should know Planck's constant. If not, it's on your formula sheet, and I actually don't have that memorized. So I'm going to look that up real quick, Planck's constant. But that is on your formula sheet, so it's really not worth memorizing if you don't already have it memorized. So from here you can substitute, or you can algebraically rearrange this equation and substitute it into this equation, which is better, honestly, because you're less likely to make a mistake in your calculator. So you'll get that the frequency is the speed of light over the wavelength, other way around. Wavelength is equal to the speed of light divided by the frequency. So now you have the wavelength, and you just need the frequency. Well, the frequency is going to be E over h, right? So now you can substitute this into the equation, C E over h. This is simply C times the reciprocal of the denominator, h divided by E, which is h times C divided by E. So you have two constants up top, and you need to find which energy to use. And it explicitly says the valence shell. And the valence shell is the most outward shell, so it's this energy term right here. So this is going to be, I do have the speed of light memorized. So this is going to be 6.26 or 626 times 10 to the negative 34th joule seconds. Again, just from your formula sheet. Also from your formula sheet. But I do have it memorized. The speed of light. On the formula sheet, I think it gives it to you in more than just 0 decimal places, but that's really all you need. 3 times 10 to the 8th meters per second divided by the energy of the valence shell, or the binding energy of the valence shell, which is 0.980 times 10 to the negative 18th joules, and evaluating this, putting in your calculator will give you 2.07 times 10 to the negative 7th, I believe, meters. That numerical value could totally be incorrect because I'm just recalling that off of memory because I don't want to waste time putting that in a calculator. But that is question number 5.